A full memory tree contains 21 nodes in which 5 are internal nodes. Then the value of m is a full memory tree is a full memory tree or a full binary tree means all the leaves should be present at the same level. The number of leaf nodes in full memory tree is given by L is equal to m minus 1 into I plus 1, where I is internal node, L is equal to leaf nodes. Total number of nodes is equal to leaf nodes plus internal nodes. Leaf nodes is given by m minus 1 into I plus 1 plus this is internal nodes. Number of leaf nodes plus number of internal nodes is nothing but total number of nodes. Here internal nodes is given as 5. So m minus 1 into 5 plus 1 plus I is 5 is equal to total number of nodes is given as 21. So here 21 is equal to 5 plus 1 6. So 21 minus 6 is 15 is equal to m minus 1 into 5. 5 1 the 5 3 za. So implies m minus 1 is equal to 3. M is equal to 4. So here we got m as 4. So here option A is the correct answer. What is the following recurrence relation in asymptotic notations? The given recurrence relation is T of n is equal to 7t n by 3 plus n square. For solving these type of problems, we use Master's theorem, which consists of 3 cases. Here T of n, we compare T of n with A into T of n by B plus f of n. So here A is equal to 7, B is equal to 3. Now let us check with case 1 of Master's theorem. Case 1. Here we have to check if f of n is order of n power log a to the base b minus epsilon. Is f of n order of n power log a to the base b minus epsilon, where epsilon should be greater than 0. Epsilon should be greater than 0. This is the first case. If this is satisfied, then we can say T of n is, if it is satisfied, if it is yes, then T of n is theta of n power log a to the base b. If this condition is satisfied, then we can express T of n as theta of n power log a to the base b. Now let us check this. Here f of n is n square. Is n square order of n power log a to the base b. Log a, here a is 7, base b is 3 minus epsilon. Epsilon should be greater than 0. We can take 0.1, 0.2, something like that, but it should be greater than 0. So n square is theta of, order of n power log 7 to the base 3 is nothing but 1 point, will be getting 1.77 minus epsilon. Here n square is n square order of n power. Here this should be greater than, epsilon should be greater than 0. This is epsilon and it should be greater than 0. So if we take 0.1, it is 0.67. If you take anything which is greater than 0 in place of epsilon, then this condition will be false. this is not satisfied. Why? Because here it is n square. We can't express n square is not order of n power 1.77 minus something which is greater than 0. So this is not satisfied. Now if case 1 is not satisfied, let us go to, we have to check with case 2. Case 2 is, in case 2 we have to check if f of n is f of n theta of n power log a to the base b into log n to the power k, where k should be greater than or equal to 0. This k should be greater than or equal to 0. This epsilon should be greater than 0 in case 1. So here f of n is n square. Let us check with second case is n square theta of n power log 7 to the base 3 into log n k. Here we can take k value as greater, any value which is greater than or equal to 0 in place of k. So is n square theta of, we got as n 1.77 log n. Even if we take, so if we take any value in place of k which is greater than 0, this condition is not satisfied. So even second case also failed. Now we have to go for case 3 of Master's theorem. Case 3. Here in this we have to check if case 3 is f of n sigma of n power log a to the base b plus epsilon and a into f of n by b should be less than or equal to sigma, this is delta, into f of n, where epsilon should be greater than 0 and sigma should be less than 1. This is the condition for case 3. So here f of n is n square sigma of n power log a to the base b, which is so here log 7 to base 3 plus epsilon and a into f of n by b. A is 7 into f of n by b, n square, f of n is n square by b is 9. Here b is f of n by b. A is 7, n by b, f of n by b is n square by 9. Should be less than or equal to delta into f of n square. So here we can take delta as 7 by 9, which is less than 1. So this condition is satisfied, and here epsilon should be greater than 0. Epsilon should be greater than 0. n square is sigma of n power log 7. This is 1.77 plus epsilon. If we take epsilon as 0.1, this condition is satisfied. So if these two conditions are satisfied, we can say f of n is, t of n is theta of f of n. So theta of f of n. So here theta of f of n is n square. So here given recurrence relation is theta of n square. Option B is the correct answer.